It's time to start writing the real code for our program now. We need to create our players, then fill in the launch method so the fun can begin. We're going to start with the easy bit, which is creating players. This needs to do several things. First, create a player sprite and name it player1. Second, create a physics body for the player that collides with bananas and set it to be not dynamic. Third, position the player at the top of the second building in the array. If you are wondering, this is why we have a buildings array that we appended the buildings to as they're being created. And fourth, add the player to the scene. Of course, we'll then do the same thing again, all four things, for player 2, except now they should be on the second to last building. The player physics body can be made using a circle, because the sprite I've used, which is the same for both players, is more or less round. Positioning those players at the top of the buildings is just a matter of adding the building's height to the player's height and dividing by 2, to offset for the way SpriteKit positions sprites based on their center. We can then add that to the building's y coordinate. First, let's make some properties. In game.swift, we have buildings and view controller. I'll add to that var player1 is an SK sprite node, implicitly unwrapped. Var player2, SK sprite node, implicitly unwrapped. Var banana is an SK sprite node, implicitly unwrapped. And we'll add one more. Var current player is 1, so we know whose player is currently taking the turn. Next, let's scroll down and find some space where we can make players. I'll say func create players. Player1 is an SK sprite node with the image named player. Player1.name is player1. Player1.physicsBody is an SK physics body with the circular radius. Player1's size width divided by 2. Like I said, they are basically round. Player1.physicsBody question mark dot category bit mask is collision types dot player dot raw value. They are a player. Player1.physicsBody question mark dot collision bit mask is collision types dot banana dot raw value. If you want to bounce off bananas. And player1.physicsBody question mark dot contact test bit mask. Please tell us about collision types dot banana dot raw value. So tell us when to hit bananas. Most importantly, physics body is dynamic is false. Don't let them be moved around by gravity or similar. For their building, we don't want to use buildings 0 in the array. That kind of hangs off halfway off the screen. We want to use buildings 1 so it's indented slightly onto the screen. So I'll say let player1 building equals our buildings array, item number 1, which is second in the array. And then player1 position is CG point. The X being player1 building dot position dot X. So center it on the center of the building. And Y will be player1 building dot position dot Y plus, this is going to do the division part, we're going to say player1 building dot size dot height plus player1 dot size dot height, then divide that by 2. Now keep in mind, these things are centered, so that'll get me the full height of the building and divide it by 2, and get me the player's height and divide it by 2, so it'll place the bottom of the player at the top of the building. Finally, we'll say add child player1. So that's all the code required to make the first player right there. Of course, we want 2 players, so I will copy and paste that code below, like that, and make the changes from player 1 to player 2. So player 1's here, and here, and here, and here, and here, and here, here, and here. Player 2 building, player 2 position, player 2 building, player 2 building, player 2 size, add player 2, player 1 building here, player 2 building, oops, like that. So basically, everywhere you see player 1 should be player 2. Don't forget to change the name as well. That's a string, so it's part of how to catch. That should be player 2. And for its building, we don't use second building. Instead, we want to say buildings.count minus 2. So go back, because minus 1 will be the last building, minus 2 will be the second to last building. So that means place player 2 at the second to last building. Now, one thing we haven't done yet is actually add in the images to be used inside the game. And the reason for that is because we want to use a special technique called texture atlases. SpriteKit does not use these things by default, which is why we haven't used them. There are bigger things to worry about after all. But this game is perfect for texture atlases, so we're going to use them now. Now, an atlas is a set of pictures that are combined into a single image. They might be stored in their original orientation, or they might be rotated. Alongside those images, the atlas also contains positions and sizes, which means to render one of those pictures, SpriteKit loads the whole atlas and just draws the small window that represents the image you want. Texture atlases allow SpriteKit to draw lots of images without having to load and unload textures. It effectively just crops the big image as needed. Even better, Xcode automatically makes these atlases for us, even rotating sprites to make them fit more efficiently. And the best bit, just like using the asset catalog, you don't need to change your code to make them work. Just load sprites the same way you've always done. We're going to use a texture atlas for our game here, so go ahead and open up the asset catalog. Right click in this big space here, and choose New Sprite Atlas. You'll see sprites appears here with one thing inside called sprite. Now go ahead and find your folder of images. I have it here on my desktop, Hacking with Swift, Project 29 files, Content, and you want to drag banana, player, player 1 throw, player 2 throw, and spark. All the images we have in our project. Drag those into that sprite texture atlas here, like that. Boom. And all drop in. And you can get rid of sprite, that's empty, it can go away. Boom, like that. So now you'll see all these things are rendered inside there. And they look like just a regular part of the asset catalog. While you're here in Finder, please also drag in hit building and hit player, our two particle emitters. Drag those into your main project. Now, even though these look like regular assets, when it gets built, it will include them in an optimized form in one big image that can load much faster and more efficiently. We haven't got to worry about it, it's wonderful. With our create players method in place, all we have to do now is call it inside did move to view. So I go to GameScene.Swift, scroll up to find did move to view. Here we go. I'll add create players there. Let's press Command R now. See how that thing looks. Okay, not bad. So you can see there's our left hand building. The gorilla / monkey is one building in there at the top nicely. And say on the opposite side, it goes one building in. Perfect. So now it's time to flesh out our launch method, which right now is currently completely empty. This is complicated. It needs to do quite a few things, such as figuring out how hard to throw a banana, figuring out the degrees angle in radians, because of course our UI has degrees, that's how people think, but SpriteKit wants radians. It will destroy any existing banana, then make a new banana, animate the players throwing bananas, and of course do the actual physics throw in the first place. Now, converting between degrees and radians is a fixed mathematical formula. It's done for us already. This is a known quantity, it's already a solved problem. This is a fixed piece of code. So I'll go ahead and make some space and make a new function down here, func deg2rad, degrees to radians. That name, it might look awful, deg2rad, but trust me, it's extremely common in the coding community. You'll see that an awful lot in other languages, other platforms. This will accept some sort of degrees integer and return a double. Inside there, we're going to return the double version of our degrees multiplied by .pi divided by 180. That's the mathematical formula for converting between degrees and radians. With that in place, let's go ahead and start writing our launch method up here. The first thing we're going to do is figure out how hard to throw the banana. Now this thing, as you can see, has a velocity parameter coming in. That's the one set by the slider. But in my playtesting, I found those values to be way too big. It's much better to use small values. However, very, very small values aren't great for players to work with. You know, they want to throw by 11.1 or 11.12 or something. It's not much fun for them. So having large values in your UI that you divide internally usually works better. So we'll start by saying, let speed equals a double version of our velocity divided by 10. Make it 1/10 the value they specified. And that's my playtesting. If you want to change that yourself, go ahead. As for the angle to throw, again we have that angle coming in, but it specifies degrees, and SpriteKit wants radians. So we're going to go ahead and convert our degrees value to radians. We can say, let radians equals deg to rad, with the degrees being our angle coming in. Next, if there is somehow an existing banana somewhere in the scene, we want to destroy it fully. Make sure it's definitely gone, because we're about to make a new banana. Now realistically, there's only ever one banana in the game at any given time, so this should never happen, but there's no harm being safe. So we'll say, if banana is not equal to nil, then banana.remove from parent, and banana is equal to nil. Get out of the game scene and free up the RAM. And with that done, we can now go ahead and make a new banana node with the right physics body, and so forth. But this time, we're going to add one bonus line of code, as you'll see. I'll say banana equals an SK_sprite node with the image named banana. Banana.name is banana. Banana.physicsBody is an SK physics body. I'm going to use circular radius again. I know obviously bananas aren't circular, but it basically is, and it's very small and very fast, and will make it spin as well, so I'm not terribly worried about that too much. Its radius is going to be its banana size width divided by 2. As for its banana physics body dot category bit mask, we'll say is collision types dot banana dot raw value. I will copy that to the next line to make my life slightly easier. Its collision bit mask is collision types dot building dot raw value, or as one pipe, collision types dot player dot raw value. Now if you remember, that or means combine these two bit masks together to make a larger number that combines both of those two values. So this means it can hit buildings or players. We want that same line for its contact test bit mask as well. So it'll go ahead and bounce off them and tell us when it does so. And now for our bonus line of code. This banana is very small, and it's going to move very fast depending how hard the player throws it. This creates a problem. It's possible that between one frame of your game scene and another frame, the banana has passed entirely through a player or a building, which would actually have caused a hit if SpriteKit were being more precise. What we can say is banana.physicsBody dot uses precise collision detection equals true. And now it'll say at every frame what I collided with, but it'll also perform calculations between frames and say between position A and position B would I have struck these objects. So it's much more precise. Now you don't want to enable this very often because it's very, very slow. You want to be very selective about it. Be careful. I've done it here because it matters. Broadly speaking, you don't want to use it. Small objects that are fast moving, fine, use it for that. Otherwise, please don't. And finally, we will say add child that banana. So it's in the game scene now. Now, one thing we haven't done is position the banana anywhere in the game scene. And this is because we don't know which player is throwing it yet. We haven't checked that. So the next part of our code is going to say, if we're player 1, position the banana over our player's position, roughly where their arm is, and make the banana spin so it spins in the direction of their movement. We'll also use this to animate the way our player looks, just briefly. Because we have the sort of player monkey sprite sort of standing still, looking bored. Let's look over here in Asset Catalog, this thing here. But we also have a throw version of that for the one player and another one for the other player. So it will either throw to the right or throw to the left depending which player it is. So we're going to use a new SK action called setTexture that lets us move between sprites. We're going to say move from this original picture up to an erased arm picture, pause just briefly, then go back down to the original picture again. And once that's done, the most important part, we're going to give our banana a good hard push in the right direction. Just like radians and degrees, this has a fixed mathematical formula. We can calculate the movement, the x and y movement of something from its angle by using sine and cosine, and multiplying that direction by the speed we want to throw. So it'll go faster in that direction. To get the x movement, we want the cosine of its angle, and the y, we want the sine of its angle. I know this might seem like a high school mathematics stuff. Sorry about that. Again, it's just a fixed mathematical formula. There's not much we can do about it. So back in our code, after this call to add child banana, we're going to say if the current player is 1, then our banana position is going to be the CG point of our x player 1 position dot x minus 30, so a bit to the left where his arm's going to be, or her arm of course. Then we'll say the y value is going to be player 1 position dot y plus 40, so a little bit up above the player so they don't kill themselves by accident. We'll then say banana dot physics body question mark dot angular velocity, that's the speed at which it's turning, and I'll say minus 20, so it'll spin around. Then we'll animate the player. We'll say there is a raise arm, which is SKAction dot set texture. It'll have SK texture, image named player 1 throw. I'll copy and paste that and call that replacement lower arm. And that will be just player like that, because they're both pitched the same for player 1 and player 2 when the arms aren't raised. We'll then have a pause action, which will be SKAction dot wait for duration. I'll do 0.15, so only a very, very small amount of time. Then a whole sequence will be an SKAction dot sequence of raising the arm, pausing just briefly, then lowering the arm again. And finally, player 1 dot run that sequence. Go ahead and run that animation on the player. So at this point, our banana has a position and is spinning in a certain direction. The last important thing we want to do is give this thing a really good hard shove in the right direction. So we'll say let impulse equals a CG vector. And it has a dx and dy. The dx is going to be the cosine of our radians multiplied by our speed. And the dy is going to be the sine of our radians multiplied by our speed. We then say banana dot physics body dot apply impulse, that impulse. And apply impulse means give this thing a push in that direction. Direction, of course, being dictated by our angle, by our speed, so it'll be a harder push in certain directions, and then same for our sine of our radians as well. After player 2, again, this is really similar code. So I'll copy and paste this first chunk of code for player 1, have an else block, and use that for player 2. Of course, there are some changes here. It's no longer minus 30 of the player's position, it will be plus 30 of player 2's position. And for the y, it's still plus 40 above the player, but of course it's player 2's y. For its spin, it's not minus 20, but plus 20. For the animation, it should be player 2 throw rather than player 1 throw. But of course, going back to player and the pause and that whole sequence, that has not changed. Once that sequence is made, it should be run on player 2 rather than player 1. And importantly, we want to flip the dx part of our vector. So the dy, how far to go up into the air, that hasn't changed. But the left and right movement, that has now changed. We want to use here minus speed. So it moves to the left rather than moving to the right. Otherwise, of course, player 2 would throw to the right as well and would never win. With that code, hopefully the game's starting to come together. I'll press Command R now, give it a try and see how it looks. So there's player 1, there's player 2. I've got 45 degree, 125. I'll just press launch, see what happens. Boom. Okay, so as you can see, the bananas don't actually explode yet. And of course, player 2 never actually gets a shot, but all in good time.